Hi everyone, this is Mrs. Crawford. Excuse me, sorry, I have a little bit of a cold, so if I sound a little funny, that's why. This section is I'm going to go over day 5 notes on verifying rigidity. Now, rigidity means that a shape does not change its size or its sides or its angles. And you can kind of think about it like the desk you are sitting in. If you move that desk like we do on quiz days, it doesn't change the desk itself. It might be turned a different way or moved across the room or, I don't know, flipped over in some cases if people get a little crazy. But you aren't actually changing the desk itself. You're not stretching the desk. You're not making it a bigger desk. You're not shrinking it down. It's rigid because it's staying exactly the same. It's the same thing with our transformations. So we're going to look at a couple different types. First of all, here is your definition for rigid and non-rigid motion. Isometry is just the word we use for things that are rigid, and rigid motion. If it's not isometric, it's not rigid motion. Kind of simple. So rigid motion preserves distance and angle measures. In other words, it keeps the side lengths the same and it keeps the angle measures the same. So the 3 types that do that are the translations, reflections, and rotations. And on your notes page, you'll see that there's a chart where you can fill in either the word rigid or the word non-rigid. And then each of those pictures before the independent practice, I want you to label them with what type it is and say whether it's rigid or non-rigid and put something in there about why, because this is going to be a question on your quiz tomorrow. So first of all, translation. That key word is shift or move. And if I look at the graph, when I go from the black to the blue shape, it shifts across. It goes left and up. But is this shape a different size than this one? Or is the size of everything different? No, it's the exact same shape. It's just moved across the screen. So that means it's rigid motion. Rigid does not change the shape itself. It just changes where it is. So that's our first example. Second example we'll do is reflection. Remember, our keyword with reflection is flip. Good review of all of our past days of notes. And this one actually flips across or reflects across the y-axis. Now it is facing a different direction, but is this side length a different measurement than this one, or are any of the others different? No, it should be exactly the same. The only thing that's different is the way it's facing. So again, this is rigid motion. The shape itself is not changing, just the direction that it's changing now. Okay. Third one in that category is rotation. Remember, our keyword with that was to turn or spin or orbit. If I look at this guy, it's turning here by 180 degrees. So it is facing a different way. It is rotated. But these side lengths, again, are exactly the same distance apart. This one is the same, and so is this one. So the sides haven't changed. The angles, therefore, wouldn't have changed. All that's changed is the way it's facing. Therefore, again, it is rigid motion. So let's take a look at some examples that are non-rigid, things that are going to change the shape. Now, we aren't going to actually draw any dilations or stretches, but you do need to know them for the quiz tomorrow because you will see some non-rigid motion questions that you have to answer. So dilation, think about if you go to the eye doctor, any of you, and you have to get your eyes dilated, it means your pupils get really, really big and it's really creepy and weird and you have those stupid glasses that you have to put on. Yeah, those aren't really fun. So dilation in math means that the picture is either going to get bigger or smaller. Now think about rigid motion. We said rigid motion means it doesn't change the shape itself. It just changes where it is on the graph. Is this shape the exact same size and shape of this one? No, obviously not. This one is definitely bigger and shrunk down when it was dilated. So this is non-rigid. Why is it non-rigid? Because the shape gets smaller. It's smaller. Okay, so that's a dilation. Second and third ones are kind of similar. They have to do with stretching and shrinking. So stretching is kind of like I take the two pieces of the shape and just pull them up or pull them down like that. Our original one is the black one here, and you can kind of see that that point C was stretched up a couple units. If you stretch something, are you changing the size of the shape? Yeah, probably. You can look at the picture and see that it's not the exact same size and shape as it originally was. That's pretty obvious. So this again is non-rigid motion, okay? Because the sides, oops, not but, because the sides are now taller or longer. Oops, because sides are longer. So non-rigid, it doesn't stay the same. Last example on here is a horizontal stretch. That means it's just pulled or shrunk on the side. You can see in this one the black is the original, and it almost looks like it got pushed in to become this blue one. Definitely not the same size and shape. It might be the same shape. It's still a rectangle, but definitely not the same size, because this black one was longer than the blue one. Again, rigid motion would mean it's the exact same shape, just a different spot. Okay, so this is non-rigid because the length is less. Okay, so you will get a very specific question tomorrow on a picture, and it will ask, is this rigid or is it non-rigid motion? So be ready for that. Make sure you understand the difference. On the back of this paper, you have a couple questions about naming the types of transformations and then doing a couple for review. So good practice for that to prepare for your quiz tomorrow.